In the often forgotten about Hyperfile. So let's give our next speaker a big hand.
My name is Dusty Evanoff. I'm a security analyst at a software company in Lenexa, and my talk's called Taking a Dump to Find a Leak. So enjoy your sausage, hamburger, pizza toppings, and all the things that remind you of bathroom humor that I won't mention again. Before I start, I'm speaking for myself, not my employer or anybody else I'm associated with. And as with any offensive talk, anything that's kind of offensive oriented, carrying out some of these things on computers you don't have permission to carry out on. You're good. All right, can you hear me? Yep. All right, so carrying out any of these types of attacks on a machine you don't have permission to do them on can land you in jail, so don't be a dick. All right, so just to get on the same page about kind of what we're doing here, we're talking about memory, we're talking about RAM, in case you're confused about what memory means. And what we're talking about is how to kind of start mining memory on a machine and looking for sensitive information, things you don't want other people to find out about or see. We're talking about Windows kind of specifically, but all of this should be pretty applicable on other machines. So if you have Unix or Linux or Mac or whatever, when you go home, play around with it. A lot of this should be pretty accessible and pretty easy to get started with. It's not a super technical thing that we're talking about today. Computers in general, how they work internally, it's kind of hard, but we're going to keep it simple. All you really need to know to follow the talk is, like when you open an application, when you start a process, when you read a file, whatever's contained in that file gets read into memory, and it gets allocated kind of its own address space, and that's where it resides. And when you interact with it, more data, maybe other instructions, also get read into memory. And that stuff ends up in a lot of weird places on your computer, and it doesn't really disappear when you're done with it, right? So yeah, why are we interested in this? Why are we talking about this? You probably have an idea right now, but in case you're not, memory is kind of like the underwear drawer of your computer. It's where you keep the things you don't want your friends or people that come over to your house to look through. You keep your personal information there, not knowingly a lot of times, passwords, banking information, private keys when you decrypt things or encrypt things, decrypt things. It's where you keep things that attackers really like to get and where you really like them not to get. So, how do we get these things? How do we get the RAM? Okay, there's a couple of ways to access RAM on your machine. One of the ways to do it is directly, and one of the ways is to find it on your disk. So, starting with just talking about how to get to RAM directly, you're going to be using something like a RAM scraper. You can find code out just by Googling. The Python example I found in like 30 seconds on GitHub, and it's really similar to what was used in the Target breach. There's some PowerShell stuff, the PowerShell Arsenal, which is kind of a spin-off of the PowerSploit project. There's codes available to look at and kind of play with. But basically what's happening is, with a RAM scraper, you're looking into process memory, and you're just searching it for a certain pattern. So if you're looking for credit card data, then you're looking for, 15 or 16 numerals that are together in a string, maybe a delimiter at the end, and running a quick loon check on it, and when you have valid data, you've got a match for what you're looking for. If you're looking for, if you see the string RSA private key in memory, then you might have another issue. If you see certain hex patterns or whatever, you can find the stuff you want pretty directly, pretty easily with it. So RAM scrapers are a little more technical in terms of programming and messing with them, but the stuff's out there if you want to play with it. It's pretty simple. So we talk about accessing memory on a disk. There's a few more options. It's not just kind of this one way of interacting with it. You may be surprised. Oh, I'm sorry. I got to back up. These guys got owned by RAM scrapers. So we're talking about memory on a disk. You have a few options, and one of the easiest options, one of the easiest things to play with and look at applications you maybe develop, applications that you use, is just to dump the process memory in Windows. you can open Task Manager and right-click on a process and go to Create Memory Dump. And you'll have a raw memory dump for whatever was in that process memory at that time. And there's some pretty easy ways to deal with that, and we'll talk about those in a little bit. But there's also other tools. If you don't want to just use Windows, maybe you want to script something, you want to do it in a shell, you have the option to use some sysinternals tools. You can do it with PowerShell, and there's probably a dozen other tools that I have no idea what they are because these things are easy to use and they're really available. Outside of just doing that, or both of these last two things, RAM scrapers and just dumping process memory, we're talking about just interacting with what's actually on RAM at the time, right? What's on your RAM cards. There are places that RAM and copies of what's in RAM exist on your disk. So what I'm saying is volatile memory sometimes isn't all that volatile, right? So if you have a Windows machine, where would you find copies of the information that you're storing in RAM?
Page file, that's it.
Yes, your page file and your Hibernation file, right? So you're keeping stuff in swap, so whenever your memory is not big enough for the things you want to put there, it's going to offload things you don't use very much to your page file, so it makes space for things that you use a lot more frequently. And that's why when you minimize an app and later on, in the day, you maximize it again, you see your little mouse spinner go, and your computer starts thinking and slows down because it's reading something back in from the disk, and it can't read as quickly from disk as it reads from memory. Your Hibernation file is, more or less, at given times, a copy of what's in your RAM, right? When you suspend your computer, you put it to sleep. It needs to know what's in RAM because it wants to cut power to that. And you keep a lot of good, juicy things there. Something some people don't know is when you actually use full disk encryption, a lot of solutions don't encrypt one or both of these files. So I've seen some wikis of lists of different products that do full disk encryption or advertise it, and at least half of them don't encrypt the Hibernation file.
So how does that work? If it's going on a, does it put it on a different partition on the drive, or is it, how does it appear if you walk up to that machine then?
I'm not sure. That's a good question.
It's a fair answer.
Homework for everybody. So if you mess with Windows very much, you're probably on a live system. If you try to copy the Hibernation or swap file, Windows is going to poop its pants and say, no, you can't do that, access denied, right? It keeps a read handle lock on files that the operating system's using. And while it's got that lock on the handle, it doesn't let any other process read from it. But it's not a big deal because you can read directly from the file system. And there are a couple tools that'll let you do it. PowerSploit has a tool called PowerSploit Project, you can find it on GitHub, has a tool called Ninja Copy that uses a C++ library that reads directly from an NTFS file system. And I'll show you later in a slide, you can actually read that PowerShell script directly into memory and execute it, so you don't have to even write a file to disk outside of the Hibernation file you copy off somewhere. There are other tools like NTFS Copy, Shadow Copy, HB Gary has a tool called fgit. You can carve stuff out, DD. So you have options. If you really want to get it, it's really not that hard. It took me about 10 minutes to figure it out, and it's pretty simple to play around with. If you don't know and you haven't played with the PowerSploit stuff, give it a try. If you just want to mess around one day and see what's in your Hibernation file. Another place you'll find memory on disk if you use VMware. Does anybody have VMware running where they work? Does anybody create snapshots of VMware's machines that are running, VM machines that are running at work? Does anybody encrypt those snapshots? Because they can be turned into raw memory images with a tool like VMSS to Core, or even with Volatility now, it supports it within the Volatility framework, which is another tool that's pretty awesome for looking at memory. So you can actually go through those things just like you can go through any other memory dump. So if you have, for example, domain logins on those machines, someone's logged in, then you can use a tool like Mimikatz to look at those domain logins in plain text. There's pretty much what you have there is completely searchable, just like any other file on disk. Which, by the way, if anybody hasn't messed with Mimikatz, it's pretty cool. If anybody is looking for a tool talk, it'd be a pretty sweet tool talk. Mimikatz, so just a note. So the idea behind the talk and kind of where I started and wanted to introduce was I was looking at a password manager called 1Password. And it's a Canadian company that runs it called Agile. Does anybody use 1Password as a password manager? Okay, they do good things. They're a good company. They're pretty smart people. I've spent the last couple weeks kind of emailing back and forth with them about this. They do well with encryption. I'm not really that smart with encryption, but is there anybody that thinks this is not a good way to encrypt your password vault? I didn't think so. So I was looking at it, and I was looking for just kind of an easy win. I just kind of wanted to see how secure it was and kind of what it looked like, and I wasn't going to throw it through a decompiler or do anything crazy with it. I just want to find, you know, 30 or 40 minutes of poking around if I could find an issue. And while I was looking at it, I dumped memory on the process, and I found that the master password was stored in plain text in memory. The way I found it was I right-clicked on the process and dumped memory, and then I used external strings to just search through it and look for any ASCII or Unicode strings and put those out to a text file. And what I got was probably 600,000 or 700,000 strings, which is kind of a lot. But when I grabbed it, I found my master password was there. It doesn't seem like that big a deal because it was just by itself. It didn't say password equals, it didn't have anything that indicated that was my password. It was one string in a sea of like 700,000, right? So the first thought I had was, who gives a shit? This is stupid. Who cares? It's not a vulnerability. No one's impressed. But I spent a little bit of time thinking about it, and I realized that, no, it's not this. If anyone follows this Twitter account, it's not quite this stupid. I realized that I could take the memory dump that I made, that I pulled strings from, and I could turn it into a dictionary file to crack my 1Password vault. And I realized that if somebody else has this on their machine, I can't probably pull memory from it, but I can carve their Hibernation file out of their hard disk. And if I find they also have a 1Password vault, I can crack it. I can create a dictionary file that's guaranteed to have the password in there. Has anyone ever tried to crack something with a dictionary file and the password hasn't been in the dictionary file? Right, this is one way to know, like, with this application, up until the most recent release, that the password's going to be there. You're going to have success. So I copied off the Hibernation file just as an exercise, and I used an Ninja copy where I reflectively read that PowerShell script into memory on the machine, so I had to write the file and executed it, and then I took strings and ran it on that file. And what I did was I looked for any string that was longer than 8 characters. So that's what the -n is, and I output that to a dump file, and then I cleaned it up some. If I was gonna just look at process memory, one thing I can do to make my file a little better is I can also run strings on the binaries, and then take those strings out of my dump file. And if you wanted to do something like that, this awk script should get it done for you. Then I just sort and unique to get rid of anything that didn't need to be there. I didn't want any duplicates. And then I'm looking for passwords, so I wanted to make a password list that met what I thought like reasonable password strength requirements were. So I grepped out anything that didn't have a lowercase letter, an uppercase letter, a numeral, and anything that had spaces I wanted gone, and looked for anything that was only within 8 to 20 characters. Because we're talking about a vault password, right? Something someone's gonna remember, not something crazy that someone's storing in a password manager. Threw it into John the Ripper. Someone had already written scripts to crack 1Password vaults if you have a dictionary list with a good password. So I used that, and on my crappy PC, which is like a dual-core i3 from like 5 or 6 years ago, it took me 27 minutes to find my 15-character long password that had upper, lowercase, and numerals. So it was really simple compared to how long it probably should have taken me if I just look at like what the entropy on this is and look at the pure math behind how long it should take to crack something like this with this encryption scheme. So also looking at it, I found that whenever I created something in my password vault and I opened it, like if I added a credit card to the vault, or if I added a password for like an email account or whatever, if I opened it and viewed it, that data was stored like in a JSON string in memory also and kind of stuck around. So I can go in and if I wanted to create a little regex that would find JSON strings in a memory dump, I could also look for that. Like I could look for strings that are 100 characters long or longer or whatever, and create a little regex to look for JSON. So it's also kind of interesting. So I started thinking about where else you could do something like this, because I haven't seen people use memory dumps or strings from memory dumps as password files. I hadn't been able to find that when I Googled around, and maybe it's because it's just really simple. It takes very little time and very little technical skill. But I just kind of poked around in a couple applications, and I found there's some other things that print your passwords in plain text in memory, like VMware vSphere client does, a remote desktop connection manager from Windows does. So like if you had an NTLM hash and you wanted to actually turn that into a password, if you could dump memory from one of these things, you have a lot better chances of using that as your password list than any kind of random dump out there. Also, Cygwin, does anyone use Cygwin on their Windows machine so they can make it look like a Unix machine? It also does the same thing, like if I FTP into something, or SFTP or whatever, I find that the password that I use ends up in memory as well. So I think there's some other places where this can be useful. If you have programs that encrypt files or do some sort of encryption on your disk, if you have password managers. I know KeePass shouldn't have this issue. They store things in like in the data protection API in Windows, so it all kind of ends up in an encrypted portion of memory, but it's something that's kind of worth taking a look at. If you find something, feel free to email me. I'm kind of interested in seeing what else goes out there. If you think of more ways to use something like this besides just pulling plain data out of a file, if you find different ways to use memory dumps to mess with people and things, yeah, shoot me a line. Takeaways for everyone. I think memory's kind of a bitch. There's not a good way to handle it very well and prevent something like this, and I don't think a lot of companies and then developers want to go through the effort of doing it. So understand the risks of what you've got and what your programs are doing. It's really easy to take a look at. It will probably take you 15, 30 minutes if it's something you think could affect you. For developers, if people are writing software, think about managing memory the way that you would manage a file that was getting written to disk. So because we find that sometimes it is, right? Your hybrid file, your VMware stuff, your page file. If you have sensitive data you're storing, just like any other application, if you don't have to store it, don't do it. If you do have to store it, know what you're doing with it. Know how the language you're writing in affects that. So like Java, you're gonna have a really hard time overwriting a string, right? Because you can't really do that in Java. You can't overwrite it in memory. It just creates a new string of that value. And look at using things like Windows DP API, the data protection API, if that's applicable to your application, or something else where you can actually write strings that are sensitive into an encrypted portion of memory before they ever hit memory in plain text. It's something that's not foolproof. It's been reversed. Like the data protection API is something that I think since 2012, people have known how to reverse it in a forensic kind of way, but at least something as simple as like dumping your process memory and making a passwordless is not going to affect you. So that's what I got. Any questions?
So other than, since they're Canadian, other than apologizing, what did the fine folks at Agile Bits have to say?
This was something that I think I'd seen in their forums. That they have a forum that's pretty active, and they actually have a lot of members of their forum. They kind of talked about this was not part of the security model. What they intended to do was to overwrite sensitive information in memory when they're finished with it. They're supposed to be doing that with private keys. When you close your vault or relock it, there's with other information. So they were concerned about it. They got a fix out. They wanted to make sure that it wasn't going to break anything. They wanted to go through proper QA, but we're really quick to respond and really responsive.
So it's patched now?
Yeah, it's patched. It was in the .80 beta, and I think 82 now is the version that's out. If you have one password, it'll actually prompt you to update. So if you update the new version, you should be good to go.
On Windows and OS 10?
Well, I haven't looked at it at Mac, so I think they use a little different setup in Mac than they do in Windows, and they're kind of more of a Mac specialty shop. I think in general that's kind of their niche, but yeah, Windows is patched.
It's great. Who else has questions? That's really cool, right?
Yeah.
Yeah, hell yeah. Let's got a hand. All right, now one of the things that we do at every meeting, we have many